Hey Science family, we are working on electron configurations and trying to do just some simple practice problems to get an idea of how this all works. So we've got our diagram, which we know that we always start from the bottom and work our way up because of the off-ball principle. We know that in a box we can only go up to 2 electrons and they have to be opposite spin. That's because of Pauli's exclusion principle. And also if we have the same energy level orbitals, we need to put 1 electron in each box before we can double them up. That's Hund's rule because electrons repel each other. So let's start with, write out the electron configuration for potassium. Potassium, when you look on the periodic table, has 19 protons, so we can assume that it also has 19 electrons. So to do that, we are going to start by filling out our chart. We've got 1, 2 electrons, move up to the next energy level, 3, 4, 5, 6, 7, 8, 9, 10. Notice that I filled them in individually, each box, each orbital box, before I doubled them up. All right, so that's 10, 11, 12, next energy level, 13, 14, 15, 16, 17, 18. That's a full energy level, so next we got to go up to level 4, and that's 19. All right, so when drawing that, it looks like potassium has 2 electrons in the 1s orbital, so that's 1s2, 2 electrons in the 2s, 6 electrons in the 2p orbital, 2 electrons in the 3s, 6 electrons in the 3p, and for 4s1, 1 electron. Add up all those electrons, that adds up to 19, and that's exactly how many electrons there are in potassium if it's neutral. So this gave us an idea not only of how many electrons does potassium have, but what energy levels the electrons are at, and also the shape of the orbitals, whether it's a circular spherical s orbital, a figure 8 style p orbital, but we also know where 90% of the time those electrons will be. The other 10%, who knows, but 90% of the time, 2 electrons should be in that area inside those orbitals. Let's look at the second example. It says, write out the electron configuration for cobalt. Now take a look at cobalt on the periodic table, and you'll see that cobalt has about 27 electrons. All right, so let's fill in our chart. Here's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Full energy level, let's move up. 19, 20, 21, 22, 23, 24, 25, 26, 27. All right, notice that I filled in every individual d orbital with 1 electron before I doubled up. Well, let's write that out. Started with energy level 1s, and there's 2 in there. Went to energy level 2s, there's 2 electrons in there. Went to 2p, and there's 6 electrons in there. 3s has 2 electrons. 3p has 6. 4s has 2. And 3d has 2, 4, 5, 6, 7. So 3d7. All right, so all 27 electrons are accounted for cobalt. This tells you the electron configuration, which is like the address for electrons. Again, using your chart, working your way from the bottom, working up, you can get that right away. Should be straightforward, okay? So thanks for listening. Hope this helped and gave you a little bit more support, and best of luck, Science fam.